Okay, in this video I'm going to solve these two problems, numbers 9 and 10 as shown. For number 9, a club with 14 members wants to elect a president, vice president, and treasurer. How many ways are there to do this? Well, this is P 14, 3, and I can write 14 factorial all over 14 minus 3 factorial. And it's the permutations. And so order does matter, and so there's lots of them, and so we don't have the extra term in the denominator. So this is 14 times 13 times 12 times 11 factorial, all divided by 11 factorial. So it becomes 14 times 13 times 12, which is exactly what we would calculate using the counting principle, building our three-person executive committee, president, vice president, and treasurer in 3 steps, 14 choices for the first step, and now that the president has been chosen, we only have 13 people who could be the vice president, and then only 12 people who could be the treasurer. And if you multiply this all out, I don't know what it equals. It equals 14 times 13 times 12, 2,184. Okay. Number 10, here we're going to do the same thing. We're going to do a president and a 3-person planning committee. How many are there? Okay, this one's more interesting. It's not just a straight P14-3 or C14-3. The number of ways of doing this, we're going to use the counting principle, and we're going to say, first of all, we're going to choose the president. And we're going to say, how many ways are there to choose the president? And there are 14 ways to choose the president out of the 14-member club. And then we're going to say in the second step, we're going to choose a 3-person committee. I'm assuming the president is not on the committee, and so we're going to choose a 3-person committee out of the remaining 13 members. And that would be C13-3. Okay? And let's go ahead and calculate this out. 14 times 13 factorial all over 13 minus 3 factorial. And this is combination, so it does have the extra thing in the denominator, which is 3 factorial. And this is, let's see, 14 times 13 times 12. 13 minus 3 is 10 times 11 times 10 factorial. 10 factorial, 3 times 2, and I won't write times 1. So the 10 factorial cancels out, and the 3 times 2 cancels with the 12, leaving a 2 in the numerator. One way or the other, it's 14 times 13 times 11 times 6. No. Careful, John. 14, 13, 11, and then the 12 canceled the 6, leaving a 2. And that's equal to 14 times 13 times 11 times 2, 4,004. Okay, let's count these another way. This is kind of a neat problem. I like this. First, we're going to choose the 3-person planning committee, C14, 3. And then we're going to choose the president from among the remaining members. How many are there after that? There are 11. So I'm going to say times 11. And let's see if this comes out to be the same thing. 14 factorial all over 14 minus 3 factorial. 3 factorial times 11. And let's see if this really is equal to the same numbers. 14 times 13 times 12. 14 minus 3 is 11, right? So times 11 factorial, all over 11 factorial, times 3 times 2. And now I have another 11 here. See that? 14 factorial is 14 times 13 times 12 times 11 factorial. That gives me the 14 factorial. The denominator is 14 minus 3 factorial, or 11 factorial. And that's why I did it like that. That's why I stopped at 11 factorial here, because I knew I was going to cancel that. And now we have 14 times 13 times the 12, and the 3 and the 2 cancel out to give a 2. And it is in fact equal to the same thing. Okay, so either way we can do it, and it's kind of neat, I think, certainly, that you can do it in either order, and as in a few, you can either choose the president first, then the committee, or the committee first, then the president, and it works out. So hope that helps.